Hello everyone, in this video we are going to discuss about Chemical Engineering GATE 2021 Process Instrumentation Dynamics and Control questions with solution. GATE 2021 question paper and answer key link is available in my description box. You can download it. Question number 53. This question from step response. A process has a transfer function g of s is equal to y of s divided by x of s, that is equal to 20 divided by 90,000 s squared plus 240 s plus 1. Initially the process is at a steady state with x is equal to 0.4 time t is equal to 0 and y is equal to 100 at time t is equal to 0. Are clear? Okay. If a step change in x is given from 0.4 to 0.5, the maximum value of the small y that will be absorbed before it reaches the new steady state is. So with the help of transfer function and magnitude value, so we are going to calculate maximum value of small y that will be absorbed before it reaches the new steady state. After calculating the maximum value of small y value, we have to round up the result to 1 decimal place. So in this problem, second order transfer function, we have steady state at a time t is equal to 0, x value is 0.4, y value 100, the time t is equal to 0. Step change in x value 0.4 to 0.5. So what is the meaning of this? So in step change, so the magnitude value 0.4 to 0.5. So what is the magnitude here? The magnitude is equal to 0.1. So the 0.5 and 0.4 difference, that is equal to 0.1. So this is the step input magnitude. So with the help of this value to calculate maximum value of the small y and capital Y difference. Capital Y is the deviation variable, small y is the output variable. Are clear? Okay. Yeah. Solution part, g of s is equal to y of s by x of s, that is equal to kp divided by tau squared s square plus 2 pi tau s plus 1. Why I am taking this formula? Why? Because the given g of s value from second order transfer function. So this is general format of the second order transfer function. This is a general formula. So given data, g of s is equal to y of s by x of s 20 divided by 90,000 s squared plus 240 s plus 1. So compare with general equation. So here tau squared is equal to 90,000. We want tau value, tau is equal to 300. 2 pi tau is equal to 240, pi is equal to 0.4. So in this equation, tau is a time constant, pi is a damping coefficient. So after calculating the pi value, we have to check the system. So whether it is overdamped system or underdamped system or critically damped system. So the pi less than 1, this is goes to underdamped system. Are you clear? Okay. So this is the underdamped system. So that's why refer this figure. This is the characteristics of second order underdamped system. So here this graph plot between time and y of t. Capital Y already I said deviation variable. So here this value is a maximum value. So this is y max. Are you clear? Okay. So this is y max. So what about the minimum value? Minimum value, that is a 0. This is a starting point. This is minimum value. What about the ultimate value? So here this is the ultimate value. So y you represent the ultimate. Are you clear? Okay. So here difference between ultimate and minimum, that is this is designated as capital B, difference between maximum and ultimate, this is designated as capital A. Are you clear? Okay. So if from this figure we are going to calculate the overshoot. So what is the meaning of overshoot? Signal or function exceeding its target. So that is overshoot. Overshoot for this diagram, capital A by B. What is a capital A? Capital A, difference between maximum response to ultimate response. So here capital B, difference between ultimate and minimum. Are you clear? Okay, yu minus y minimum. This is capital A, y max minus y ultimate. Okay, so this is A and B. Ratio between these two, that is equal to overshoot. Overshoot can be calculated by using this formula, exponential of minus pi divided by root of 1 minus pi square. Already pi values are calculated value. I said the pi is a damping coefficient. This is under damped system. So the pi is less than 1. Substitute this value, find out overshoot 0.2538. Okay. So this is the overshoot value. So what about the y max? So refer this diagram, capital Y max. So already I said the capital Y max is equal to, so up to this B, from ultimate to Y max, that is a capital A. So from initial to end, so the what is the Y max here? A plus B value. Are you clear? Okay. So the here capital Y max is equal to A plus B. So from this diagram, we should take capital Y max, that is equal to B plus A. Okay. So generally deviation variable. Deviation variable means capital Y is equal to, so here unsteady state minus steady state. So the unsteady state means that is small y max minus that is ys. Are you clear? Okay, unsteady state minus steady state. So this is the deviation variable. Generally deviation variable is defined the difference between unsteady state and steady state. So from this we want the maximum value of the response before it reaches the steady state. So here small y max is equal to, from this is ys plus y max. So ys is a steady state value. Capital Y max from this diagram A plus B. So from this small y max is equal to, so this value already given is right, ys value already given data. This is 100 plus capital Y max from this diagram A plus B. Are you clear? Okay. So the small y max is equal to 100 plus A plus B. Okay. So we have small y max. Already I said the small y is the output variable. Capital Y is a deviation variable. Okay. Deviation output variable. So we want ultimate value of this ultimate value. So the capital Y of t is equal to B. So the refer this diagram. So this is up to this capital B is right. So this is ultimate value. Ultimate value means this is capital B is equal to ultimate value minus minimum value. Minimum value we should take, that is a 0. Automatically ultimate value is equal to B. Are you clear? Okay. So we should take y of t ultimate or y ultimate is equal to capital B. So final value theorem, limit of t tending to infinity, y of t is equal to limit of s tending to 0, s into y of s. So here we want y of s. How to calculate the y of s value? So we have the transfer function. So this is given data. We should take that given data y of s by x of s, that is equal to second order transfer function 20 by 90,000 s squared plus 240 s plus 1. Are you clear? Okay. So we want x of s. Once you know the x of s value, then only calculate the capital Y of s. How to calculate the x of s value? So the x of s meaning that is a step change magnitude. So the what is a step change magnitude? Step change from 0.4 to 0.5. Okay. So this is starting. This is reach the steady state 0.4 to 0.5. So the difference between these two. So that is magnitude, step change magnitude. So here 0.5 minus 0.4, that is 0.1. We should take x of t is equal to 0.1. So we want x of s. So time domain goes to s domain. we should take Laplace transform. So x of s is equal to 0.1 divided by s. So after calculating the x of s, substitute in this expression, find out the capital Y of s. So the capital Y of s is equal to 20 into 0.1 divided by s into 90,000 s square plus 240 s plus 1. Are you clear? Okay, this is the capital Y of s. So final value theorem, limit y of t tending to infinitive, that is equal to limit s tending to 0 s into why? Because here in right hand side final value theorem s into y of s. So the substitute y of s in final value theorem, s into 20 into 0.1 divided by s into 90,000 s squared plus 240 s plus 1. So the s's are cancelled. So the finally we get capital Y of t is equal to here substitute s tending to 0, here 0, this is also 0, finally we get 1, 20 into 0.1 divided by 1. So we get 2. So what is Y of t? Y of t is the ultimate value. Ultimate value is designated as capital B. So finally capital B is equal to 2. So we want A by B. A by B mean B values are 2, find out the A value. So A is equal to 0.5076. Are you clear? Okay. So here Y max is equal to A plus B. Already we have Y max is equal to A plus B. Refer the diagram, previous diagram. So here A known A, B also calculated value. Substitute here, find out the capital Y max. Once you know the capital Y max value, substitute in this expression, find out the small y max. This is the answer of this problem, 102.5076. Are you clear? Okay. So the range of the problem is this is we have to round up this value 102.5. This is also the correct answer. Okay. 102.4 to 102.6. There is a range is there. So between the range we get 102.507. We should take only 102.5. That is our correct answer. Okay. For further related videos, you can like, share and subscribe my channel. Thank you.